Chapter 2 grouping or combination of capacitors. Grouping or combination of capacitors. कैपेसिटर्स जो होते हैं उनको हम ग्रुप कर सकते हैं दो तरीके से, सीरीज में पहला और दूसरा पैरेलल. तो दो कॉम्बिनेशन, सीरीज एंड पैरेलल, और वी कैन हैव अ थर्ड वन दैट इज द मिक्स्ड, वी कैन डील विद later on. Now let us take first series combination. Two or more capacitors are said to be in series if the right plate of one capacitor is connected to the left plate of the other capacitor such that magnitude of the charge on each capacitor is same. तो हम दो या दो से ज्यादा कैपेसिटर को तब सीरीज में कहते हैं जब एक राइट प्लेट दूसरे के लेफ्ट प्लेट दूसरे के राइट प्लेट से कनेक्टेड हो, और जो जितने भी उसमें ये कैपेसिटर्स हैं उनमें हर एक में चार्ज सेम होना चाहिए, तब वो हम सीरीज में कह सकते हैं. लेट अस सपोज दैट we have a capacitor C1 having capacity C1. The right plate of this first capacitor is connected to the left plate of the second capacitor having capacity C2, and let us say we have three capacitors, so C3, the left of second capacitor is connected to the right plate of the third capacitor. Now if this arrangement is given a potential V. Okay? Now, because of potential, this will be charged positively, and this will attract a negative charge towards this second plate. So this will be negatively charged. This will be positively charged. Potential is applied because we have applied some voltage or a cell here. Okay. Now this is negative, because since negative has been, नेगेटिव को यहाँ खींचा गया, पुल किया, तो यहाँ पर पॉजिटिव रहेगा चार्ज. तो ये भी माइनस क्यों होगा, ये प्लस क्यों होगा? Because of this positive, negative will be attracted towards this. It will have same negative charge. Similarly, this will have positive charge, and this will have negative charge. So charge on all the three capacitors is same. Now, Potential will not be same. There will be a potential drop. V1 here, V1, V2 between second plate, and V3 here. Okay, this is C3 capacitor. Now, potential has been divided into three parts. One, which potential drop across the first capacitor, V2 potential drop against the second capacitor, and V3 the potential drop across the third capacitor. So total sum will be total potential will be V, which will be equal to V1 plus V2 plus V3. Charges Q, which is given to the first plate. Okay, so we apply this. What we will get now, V will be total potential across all the three capacitors will be equal to V1 potential drop across first capacitor, V2 the potential drop against second capacitor, and V3 potential drop against second capacitor. Now also we know that the total charge on first capacitor is Q, that will be equal to C1 V1. Similarly, Q is the same charge across the capacitor 2, it will be C2 V2. Q along the charge on the third capacitor against Q, that is C3 V3. Okay, from this what we'll get, from this we get Q by cross multiply, Q by C1 is equal to V1. Similarly, Q by C2 is equal to V2. Q by C3 is equal to V3. So substituting this in equation 1, we get V is equal to V1 के बदले में लिखेंगे Q C1, V2 के बदले में लिखेंगे Q C2, V3 के बदले में लिखेंगे Q C3. Also, Q is equal to C V, where C is the total capacitance of the capacitor which have been connected in series. Let us write as CS. So substituting in this equation, here in equation, let us say this is 1, in equation 2, we will get V is equal to Q के बदले में CV. So Q can be taken outside this. Q 1 by C1 plus 1 by C2 plus 1 by C3. Now we will substitute for Q. That is V is equal to CSV into 1 by C1 plus 1 by C2 plus 1 by C3. V and V will cancel out. So CS will be equal to this will be equal to इसको क्रॉस मल्टीपल करेंगे, यहाँ 1 है, 1 by CS will be equal to 1 by C1 plus 1 by C2 1 by C3. This is the total capacitance of the capacitors in series. Okay, the reciprocal of equivalent capacitance of the three capacitors is equal to sum of the reciprocals of the capacitance. So if we had only two capacitors, or we can write simply, if we have n capacitors, we can write summation 1 upon C I runs from 1 to n, that is equal to 1 by CS. अगर हमारे पास n कैपेसिटर सीरीज में है, तो अगर दो ही कैपेसिटर हो सीरीज में, तो हम क्या लिख सकते हैं, 1 by CS will be equal to 1 by C1 plus 1 by C2, और CS 1 by CS is equal to C2 plus C1 divided by C1 C2, or CS will be equal to C1 C2 divided by C1 plus C2. So this is the equivalent capacitance for two capacitors. If C1 is equal to C2 is equal to C, then what we have, CS will be equal to C square divided by 2C, or this cancel, so CS will be C by 2. So it will be half of the capacitance. It means that when we put the capacitance in series, then the total the total uh, capacitance is less than the individual capacitors, or less than the least of the capacitors. Okay. Now next, capacitors in parallel. तो let us suppose that हमारे पास तीन capacitors हैं, C1, C2 having capacity C1, C2 and C3 are connected to a common potential like this. Now this is the serial parallel arrangement of three capacitors. So we say that these three capacitors said to be in parallel when when all the plates all the left plates of the capacitor connected to one point, let us say here at A, and all the other plates are connected to the next other point at a common point, let us say B, and potential is applied across this. In this case, the potential across all the capacitors will be same, that will be V, which is applied here. But because of branching, charges will be different. Let us say the charge on this is Q1 as per its capacity, charge on this is Q2, and charge on third capacity is Q3. Okay. Now here, if total charge this system is given Q, then it will be equal to Q1, let's say small q, Q1 plus Q2 plus Q3. Okay. Now we know that Q is equal to CV. Q is equal to CV. Now Q is equal to CV, और चूंकि here parallel है इसको लिखें C parallel. Okay. Now potential is same, so we will write Q is equal to CV. Now Q1 will be equal to C1V. Q2 will be equal to C2V. Q3 will be equal to C3V. So substituting all of these in this equation 1, what we will get? We will get C parallel V will be equal to C1V plus C2V plus C3V. Taking V common, it will cancel with it. We will get C parallel is equal to C1 plus C2 plus C3. So, or in general, we can write C I goes from 1 to n, that is C parallel. तो पैरेलल कॉम्बिनेशन में क्या होता है, जितनी भी कैपेसिटेंस है वो ऐड हो जाती है. So the total equivalent capacitance is equal to the sum of all the capacitors. So it will be capacitance in parallel gets increased. So when we want to increase the this capacity, we arrange the capacitors in parallels. Okay.